Good morning, students. Today we will discuss Lorentz transformation equations, that is, the derivation of these equations, which is very important. First of all, we will know what are Lorentz transformation equations. It is a set of four equations which enables us to find the relation between space and time coordinates of an event in two different inertial frames of references. Let the frames are f and f dash. In accordance with the postulates of special theory of relativity. So these equations can be drawn in accordance with the postulates of special theory of relativity, which I have already discussed. Let the two frames of references f and f dash. It may be s and s dash, f and f dash. Just symbols are used. In which f frame is at rest and f dash is moving with constant velocity. So both frames are inertial frames because law of inertia, that is velocity is 0 and velocity is constant. Let the pulse of light be generated at t is equal to 0, means at any time a pulse of light is generated from the origin and spread out in space. At the same time, frame f dash starts moving with constant velocity v along positive x-axis. This frame is moving only along x-axis. It is not going to y and z-axis. We will study only x component variations. The transformation equations of x and x dash can be written as x dash is equal to k into x minus vt. That is, x dash is a function of x and t and k is proportionality constant. So this idea came from the equation of Galilean transformation, which we have already studied. Here k is another constant, new constant. So we have to find the value of this k. What is this k? The inverse relation can be written as, inverse means as x dash is a function of x and t, similarly in inverse case x is a function of x dash and t dash. So on the same lines as equation number 1, the equation number 2 has been written, that is x is equal to k into x dash plus vt dash. Here t is not equal to t dash, means t is also variable, also relative to the motion of the frame. Putting the value of x dash from equation number 1 in equation number 2, that is this into this, and we will get x is equal to this. And on rearranging this equation, we can get t dash is equal to kt minus kx upon v into 1 minus 1 upon k square. So this is equation number 3. Now according to second postulate of special theory of relativity, that is, the speed of light always remain constant, that is c is constant. So the velocity of light which spreads out should be same in both frames. Therefore x is equal to ct and x dash is equal to ct dash. So this is the formula of distance is equal to velocity into time, but c is constant or same in both equations because c is constant. So putting the values of x and x dash from equation number 4, this in equation number 1 in the previous slide, in this equation, and we will get this equation, that is ct dash is equal to kt into c minus v. Similarly, using 4 in equation number 2, we will get ct is equal to kt dash into c plus v, and multiplying this 5th and 6th equation, both equations, we will get c square into t dash is equal to k square into t dash into c square minus v square. So on solving, you will get k is equal to plus minus 1 over 1 minus v square upon c square under root. This is called relativity factor or Lorentz factor. using equation number 8, this equation. In equation number 1, in the previous slide, we get x dash is equal to x minus vt over 1 minus v square upon c square. So this is the first Lorentz equation in x-axis or x component. Similarly, using equation number 7 in equation number 3, we get t dash equal to kt minus kx upon v into 1 minus c square minus v square upon c square. And on solving, we get t dash is equal to t minus x into v upon c square over 1 minus v square upon c square under root. So this is fourth equation, the equation of time. The equation for y-axis and z-axis are y dash is equal to y and z dash is equal to z. So both are same because the frame f dash is moving only along x-axis. So there is no change in the equation of y and z equations. Therefore, these equations are same, that is y dash is equal to y and z dash is equal to z. So these are called Lorentz transformation equations. If the frame f is moving with velocity v along the negative x-axis, that is, if this frame is moving in reverse direction, in this direction, that is minus x-axis, then velocity is taken as minus v. This one. Then the transformation equations become x is equal to x dash plus vt dash over 1 minus v square upon c square under root, and y is equal to y dash, z is equal to z dash, and t is equal to t dash plus x dash v upon c square over 1 minus v square upon c square under root. So in these equations, v is taken as minus v and x, y, z, t will be changed to x dash, y dash, z dash and t dash. So the set of this equation is called inverse Lorentz transformation equations. If speed of moving frame is much smaller than the velocity of light, then the Lorentz equations reduces to Galilean transformation equations. That is, if we put the value of v is 0 in these equations, then x become x dash, y dash, z dash. Similarly, we will get Galilean transformation equations. So on summarizing, direct and inverse equations can be obtained by interchanging coordinates, that is, coordinates of a point in first f frame, that is x by z t into x dash, y dash, z dash and t dash and vice versa. Both can be interchanged. Or second, replacing velocity v with negative v, that is v2 minus v. So this is the set of direct equations and it is a set of inverse equations, as we have already proved here. That is x dash equal to x minus vt upon 1 minus v square upon c square under root, y dash equal to y, z dash equal to z, t dash equal to t minus v upon c square into x over 1 minus v square upon c square under root. And if we change these coordinates, then we will get these equations, that is x dash become x and x become x dash and minus v, that is minus minus plus, so plus vt dash over factor. The factor remains same because when we change v into minus v, then square of minus v is again v square, that is 1 minus v square upon c square. So this factor remains same. So this is called relativity factor or Lorentz factor. And similarly, y dash become y become y dash, and z dash become z, z become z dash, and similarly for time. So these are the set of direct and inverse equations. So thank you very much.